Yeah, hello and welcome to our lecture series on climate protection. Today is our third lecture. As you have read in the newspaper, on the night of the 22nd of October, a rockfall on the ski slope on the Pfluger Glacier occurred. And so Jan Beutel's lecture is very topical because the consequences of climate change and the thawing of permafrost are obvious. Jan Beutel received his doctorate at ETH Zurich in technical engineering, computer science. After a research stay at Berkeley Wireless Research Center in the US, he worked on as a researcher at the Institute of Technical Informatics and Communication Network of ETH Zurich. In 2020, Beutel was recognized as Professor of Computer Science with a specialization in point of computer engineering to the University of Innsbruck at the Institute of Computer Science Embedded Systems Group. His research interest is on wireless sensor networks for monitoring changes in the mountain areas. Jan Beutel investigated the permafrost and the prevailing climate in an outdoor laboratory on the Matterhorn. His data helped to assess the climate change in the mountain areas quantitatively, identify natural hazards, and form the basis of forecast. His lecture of today is on climate impacts and response in the high Alpine Cryosphere. Welcome, Jan Beutel. Thank you very much for coming.
Okay. Hello, everyone. Thank you, Rainer, for the kind introduction. So today I will be reporting a bit about our research, but also I'll be taking a second hat. So I'm also a mountain guide, and I grew up in the area, as we will see and hear later on. And I want to talk a little bit about what's going on beyond the very popularly discussed glacial retreat and less white and less ice on the very high mountains, the consequences, and also the response. There will also be the word adaptation used, but I chose deliberately here to really talk about the response of the mountains and also the response of society in some part, although there I'm more a spectator and participant and not so much actor and key. So like Rainer said, for many years we've been investigating and using autonomous wireless networked sensors that feed us information, observations in real time and in very high fidelity into today's digital world. And we're applying this to the very steep and the very high corners of mountain environments, as you will see. So that's a rather unique and rather special corner of geosciences and applications. And much of our research started and is still a flagship activity when a large rockfall occurred in 2003, as you see here on the Matterhorn Hörnli Ridge in the middle of climbing season, July 15th. No one got hurt. It happened at 10 in the morning, so the dominant part of the alpinists either was above, somewhere between this spot and the summit, or had returned during the night, so pure luck. And this was very, very big in the media. There was a huge response. Newspapers in Japan wrote, well, tourism in Switzerland and Europe is doomed, you know, don't go there anymore. Of course, that is not true, but that also triggered science, because what was visible here is that you see all this bare ice melting on the surface. So the photo is really from a day or 2 days just after. Concerning the whole mountain, of course, this is just a little miniature scar The mountain still stands still today in all its beauty and all its size, but it's a very notable thing, and research started to ask questions, what's really happening there? And this will be part of my lecture part today. So since then, we've been using these wireless sensors together with partners also across the border to Italy to really build a very high intensity laboratory on the mountain, a reference site for high mountain research, which is now, since I've come to Innsbruck, run out of Innsbruck. So the Habsburg flag got a little bit closer to the Matterhorn like in ancient days. The goal of our research is really process studies, so fundamentals of understanding root causes of mostly gravitational hazards, as you see here from the Cengalo incident, and more also, because we have longer observation periods in our data, climate impacts in the mountain cryosphere. And concerning the climate, this is of course well known and well documented. So we have this temperature anomaly since many decades. So it's getting warmer and warmer and warmer. And when I look at this, I see especially that in the recent data, the recent years, but also quarters, as we see, this peak is just peaking out. It's not just a trend going up, but we have a doubling and a quadrupling, and every new data point we see actually has further distance to the long-term average. That's of course, this is global data, but of course, as we know from pure physics, this is amplified at the poles, and the mountain environments at altitude are the third pole. So also there, it is known to have more significance. In the Alps, we are very lucky that we have very dense observations and also very old observations. You see here from Switzerland, a different view on the annual temperature anomaly with regional differences, and you see this very same trend. Also in Austria, we have this data. We're very lucky. So the mountain countries have been at the forefront in the very early days in capturing evidence, capturing data. So Austria has one of the oldest temperature records. But of course, it's not a direct measurement out of mountain environments. But this is, of course, an aggregate of weather stations that are dominantly near cities and in valleys or in the flat parts of Austria. And this is really where our research is contributing to gaining more knowledge. And apart from this temperature anomaly, up and down, it's regularly being discussed. We also regularly see the reports, like here by a renowned glaciologist colleague, Matthias Huss, from ETH and GLAMOS, head of the glacier monitoring in Switzerland. And of course, these very spectacular difference pictures from the very last year. So here, the two very hot summers, 22 and 23, account for approximately 10% volume loss on Swiss glaciers alone. Yeah. Okay. And so this is the part that's really, to my experience, well known, well traveled, discussed. There's very active research, and also policy making is responding to this. Yeah. But now, mountains are much more complex. As you can see here on this time-lapse picture here, there's much more than just glaciers. Yeah? It's not just glaciers, and it's also not just summer and winter. And I want to give a bit of an understanding of what's exactly happening in the mountains, how this works, and what the consequences are. And for this, we need a bit of, high order process understanding. So I'll talk about the relationship of ice in soil and rock, permafrost, rock wall stability, and also increasingly monitored mass movements. And as you see here also, we've been going out with different forms of in situ laboratories into the mountains to quantify this and do good research there, and also working together with authorities on decision making. Yeah. So what's happening? Again, to start off, glacial retreat. Yeah, these are the pictures we've seen many times. It's just every time again, it's stunning. Just a few years and you see a complete different change. Yeah, this is observed on most glaciers in the Alps, as you see here on the Aletsch Glacier. In the large scale, but also in the small scale. So this is just a 1 year difference that you see here on Wildstrubel, also something Matthias Huss put together. So you see very small time scales and also very small spatial scales here. The other direction, other continents, other sizes. This is taken from Alaska some decades back. If we look at recent years, what we find is not just glacial retreat, but completely new landscapes. Yeah? Suddenly, this is a fjord. It used to be a high alpine glacier environment, no plants. You see all these trees. All these trees in the foreground have grown since the 40s. And this by no means is not new. Our planet has evolved all along. Yeah? The history of the Earth is full of change and adaptation. So what's also happening, what is discussed a little bit, more and more importance is that the water system and its balance is completely out of whack and it's completely changing. And of course, this is then responding. Yeah, so we have new bodies of waters. They're not just an opportunity for nice photos, but they also offer a threat if you have something falling down from the side into this bathtub. That was documented in Bayonne, where they built a hydropower plant in the 60s and had severe consequences. Yeah. And not just still bodies of water, not the rivers, but also in the pores and on the surface, things are changing, as we will be seeing. Yeah. Another thing that's happening is that mountains are getting steeper. As glacier retreat, not only in the basins and on moderate slopes, but also in very steep slopes, they get steeper. They expose different forms of terrain. You see more and more dark colors, black, gray, brown rock faces. So they get steeper, and also this rock, which was here covered with ice, and you have to think of it like one of those plastic tablecloths to protect, you know, the nice one underneath. And the system changes. So, and steeper does not inherently mean more dangerous, but of course, yeah, steep is typically something where stability is more of a concern than in flat or semi-flat areas. Yeah. What's also happening is that, and this has been documented and is visible everywhere, is large-scale destabilization processes. When you're in alpinist training, and especially in a mountain guide, it's kind of the 101, don't go into moraine areas. Yeah. Because they're prone to rockfall and slipping and so on, and because they're oversteepened and they're fragile, and they're a very short-term development. But what we see is that really we see large-scale destabilization and terrain movement everywhere, especially in the high alpine environment, and that, of course, is not something that is very healthy. Yeah? And very easy to cope with. Yeah? So when you see here this difference, yeah, there's lots of material being transported, not just the ice and the water, and of course seasonal snow. Then something that Wilfried Heberli, former professor at the University of Zurich, has been going around for at least 3 decades with his keynote talks all around the world. It is now very well known that there's multi-hazard cascades. So in mountain environments, if you have a larger rockfall, as you see here on the top. So on the Pizzcengalo a couple years back, we had to see if I can get the laser pointer back. Yes, so here, this is where rock detached quite a bit. We will see more of that later. Then it fell on top of a glacier. You can't see the glacier anymore because it got pulverized and melted. And of course, then the rock dust, the crumble, the sand, plus the liquefied water went downslope out of the valley through the Val Bondasca, past the village of Bondo, onto the cantonal road. I'll come back to this scenario 2 times more later on. So multi-hazard cascades is really important. It's recognized globally as a huge threat, and something where yeah, there's expertise. I mean, there's development, but there's not tremendous amount of attention on this. It's basically the specialists talking to the specialists. Returning closer here to Innsbruck, just around the corner, Pitztal, Mittelberg, Ferner, same situation, same things happening there. So if we fast forward here a few decades, of course, not just the glacier retreat, but many other things. And what Rainer already mentioned earlier, this is not just put into the media because of glacial melt, but because there's severe usage conflicts in the interpretation and the execution. Different groups have different opinions and different doing, and so this is something that, you know, being from Pitztal and having lived in Switzerland, I kind of was hearing it through WhatsApp and through my binoculars, you know, from the distance. Now I'm back home and see it every day in the news. So that's of course a big concern of our times of our habitat. And this is not, you know, this is just the part we witness because we are here. In other parts of the world, the same thing happens. There's these usage conflicts. And concerning spending your free time going to the mountains, alpinists, also guides, of course, making money out of this. You need new strategies for alpinism, for ascent, new routes. This is from Korvac. Still looks pretty easy, but what used to be just a glacier trek up the ridge here and back down now is through all this rubbish and rubble. And of course, there's completely different risks and also requirements on people that go to the mountains in these environments. Again, closer to us, I mean, Korvac is not so far away, St. Moritz, but here Wildspitze. On the left, this is during my guiding course, together with Hans-Jörg Auer from Ötztal, one of the best alpinists of our time, as we put in ice crews coming down here. Yeah, so that was not an easy walk. Yeah, if you look at it last year, it looks quite different. If you look at it this year, it's completely shocking. Yeah. So just for the people that kind of know the area, maybe. So this group here, that's the same as this part here on the side. Yeah. And of course, yes, this is earlier in the season. There's still a little bit of snow on top, but you see what we have here. Yeah. So suddenly, the plastic tablecloth that prevented fluid water, rainwater, snow melt from going deep into the rocks is torn off. And what we have now is of course, increasing rain. And so what's happening on a horizontal plane in high latitude environments, not exclusively, I mean, there's shorelines, they do have mountains and so on, but dominantly on a horizontal plane, happens on a tilted plane in mountain environments. So what's the same in mountain areas as in high latitude environments is that observations show in deep boreholes that permafrost is steadily warming at about 0.1 to 0.2 degrees per centigrade. And you see here, these are 10-meter deep boreholes from Switzerland, averaged out, and you see that there's a cluster here very close to zero, so that's permafrost that will be no more pretty soon. Yeah, and this is in agreement with global observations, also in high latitude environments. But what is really special for mountain areas is this huge spread of conditions. You see here, some of them are much colder than others, and some of them have a much more amplitude than others. And that really points at why it's so complex to understand and to handle. Yeah? And this interacts, of course, with weather and climate at the slope angle. And the first order commentary from climate scientists would be, well, okay, that's just a cosine of alpha, you know, but it's not as easy as that. Yeah. In the context of climate evidence, I scaled these borehole data here, and you see the oldest one is dating back to just over 30 years. That's on Motel Kovac in Engadin, here up the Inn, so it's very, very close to us. But you see, of course, that this evidence from mountain permafrost relative to evidence of detailed climate measurement is very, very small and is very, very recent, right? So therefore, of course, also the experience and the context that we can build is very recent. Yeah. What's extremely difficult is the complex topography. You see here a thermal model that Janet Netzley did during her PhD many years ago. And you see very nicely, I think, that these different expositions, different altitude levels, the different compartments of mountain areas play a huge role. Yeah, this is just geometry and temperature, what you see here. No other influence factor. And there's many influence factors, of course. Yeah. So this is kind of a first group of model, and of course she also did a bit of a time-lapse scenario where permafrost boundary would possibly lie from today, 100 years and 200 years into the future. Yeah. And what you see here on the example of the Matterhorn is that the north face is still going to remain frozen for the foreseeable future, but the base of the north face is not. And of course, other expositions are changed. But of course, there's a or a low realism in this model. It's just a first shot. Yeah. And what we also know is, of course, primary failure mechanisms. There's erosion. Our landscapes have eroded for millennia, even more. And we also know the influence of fractures. And of course, when these fractures develop, larger portions will fall down. But what we have only very limited knowledge is based on real field measurements, very good models for prognosing this. And this is something that we are working on heavily. Yeah, but the primary failure mechanism, like in all structural mechanics, is, you know, under certain loading and geometry and material properties, things break at some point in time. And together with a colleague, Michael Krautblatter in Munich, and Samuel Weber in Davos and some others, we are working over many years to detail out these models with more detail. And one of the surprising input factors is really not new. Yeah, it's not a new sauce. Yeah. Oops, I lost the slide. Sorry. Can I go back? Okay. No, we'll go without the slide. Okay. So I lost the historic slide. So in the 30s, there were experiments on rock structural strength and ductile stresses and so on, and their reaction to temperature. So the strength property, the resistance the materials itself have been under temperature conditions have been known for a long time, and they reduce a lot when temperature changes. And recent experiments here show that especially during thaw of rock samples in the lab, you reduce strength on the order of many tens of percent. So depending on which parameter you look at, 20% to 60% reduction in structural integrity and strength. Yeah, that means, you know, going from rock solid to really a piece of cake. Yeah, you throw that at the wall, it it changes a lot. Yeah, and there's also some studies that show in a reasonably accurate way increased rockfall observations. There's lots of talk about that. It's very hard to quantify. But this one from Ludo Ravanel, where they really investigated a lot of recent scars in the Chamonix Valley, and they also dated the scar surfaces, really shows a solid quantitative results that that rockfall dominantly occurs during warm periods, yeah, over longer timescales and shorter timescales. Yeah. Another influence factor is, of course, the availability and mobility of water. I mentioned earlier that our water system is pretty out of whack. This is snow height in Yamtal over the last couple of years, and last year we had this big rockfall that I'll show in a second from Fluchthorn. So this is the day Fluchthorn detached, and of course you see here the problem. Fluchthorn is 3,200 meters high. It detached at the summit, but the best data we have is, of course, from Yamtal 500 meters lower. So we have to do a lot of inference to bring it together. But you see that really it detached during or very shortly after a snow melt, yeah, if you extrapolate that. Also, looking at data in the context of Fluchthorn, you see ground temperatures at 1 meter depth showing very significant warming months earlier than the Fluchthorn detached. The best I could bring into context is from a similar environment, similar altitude, but different climatic forcing on the Matterhorn in the lower right. You see here, sorry, the copy paste 8 something, but this is the date of the detachment. This is a 1 year plot, and the horizontal line is 0 degrees. So you see here on south facing rock, same altitude, we've been, the rock has been thawing for months already, yeah, below 0 degree. And this strength, tensile strength level, shear strength, and so on, kicks in. The best we have in measurements to back up or to let us interpret what's going on in Fluchthorn is from far away. There's 2 boreholes, one in Sonnenblick, one in Kitzsteinhorn. The one in Sonnenblick here is on a plateau that's snow covered. So at the time of the detachment, we're still in full-on snow melt locally on this plateau. So that's not really something we can use to compare this very steep environment. And the other one is at Kitzsteinhorn in a different slope aspect out there. And the main message I want to give to you is in Austria we have really only very, very little evidence to cope with these questions like the Fluchthorn. Another observation, and what's been known and quantified for many years, are increasing movements, surface velocities observed in the mountain cryosphere. This is from a rock glacier in Randa, the valley leading into Zermatt. Here, you see here this rock glacier, and it's detaching. It's in crisis mode here at the front. The church tower of Randa is down below these trees that you see on the bottom here. It's about 1,500 meters vertical from here, where the material is detaching, to the village. To give you a perspective, that's from the highest peaks smack into the bottom of Ötztal or Pitztal, yeah, 1,500 meters. They have over there, things are a little bit bigger. There's another 1,500 meters to the summit on top. Yeah? And during crisis years, when we started to work on a project in the area, this portion here was moving at 140 meters per year. Okay. That's, I think, from here to Ubicet, maybe, per year. Okay. And there's a mayor responsible down there for everyone. Yeah. That's an extreme case. Yeah. This is historic evidence, one valley over above Herbricken, that in the course of the project that I discovered. So this is not something new, but it comes in waves. And the locals, they call this the Labkurche. Yeah. And it's a semi-landslide cryosphere thing. So you see it here, up here, okay? That's 1,500 vertical down here to Herbricken. And they were evacuated in the 50s, in 59, because of gravitational natural hazards from the cryosphere. Yeah? And this is an example of surging, spontaneous, accelerating slope movements from around here. So in Ötztal and Obergurgl, there's 2 rock glaciers that were first investigated here by Gernot Patzelt and Wilfried Heberli in '82. Really cool old paper to read and great illustrations that they have. Then Gernot Patzelt, many others, and we've recently, we're getting multiple people together from ÖAW, from Uni Innsbruck, from Vienna, and so on, to do more research, because this rock glacier here is not just of historic importance, but the frontal part here is accelerated in the last 10, 15 years, about 5 to 10x of what was observed before. Yeah, and of course the question is how this continues, and whether measures have to be taken. Yeah. So rock glacier and these velocity observations or these movement observations are churning out a lot of research in the last years. There's a lot of models being put out, observations, new methods. This is one example, just to tease you a little bit that there's lots going on. There's much less in steeper rock walls. Yeah? And with all this together, so new methods, old knowledge, evidence, some of it abundant, some of it scarce, of course, we can then build models such as this animation from Ale Tickera and John Gome. This is Pfluger la Wieshorn, so Silvretta, to really understand the impact of gravitational natural hazards. This is special because it was also a cascade, so rock fall onto snow, and then it slides further than if it was just rockfall. And of course, the big problem is that high quality observations are very hard to obtain. You have to be super lucky to film this. Yeah, and we are super lucky and grateful that today these observations propagate. Yeah, they propagate into our researchers' WhatsApp and Dropbox and so on, right? But really to gain evidence from the field, to be able to extend our expertise and contribute to the dialogue is really difficult and requires luck and persistence over many decades. Luckily, large cascading events are rare. Yeah, they are not. They don't happen. Every week on a worldwide scale. This is also a by chance video from someone climbing on the side, witnessing the Pitzcengalo from up above. Yeah. This one was the biggest in in the Eastern Alps with over 3 million cubic meters falling off the mountainside. It was by no means the first time Pitchengelo said hello. There was a first rockfall of 1 million in 2014, but it was in winter, and it didn't disintegrate the glacier below, and it didn't have this cascading debris flow out of the valley out there. Nevertheless, this one, of course, was very intense, also with 8 people dying. That's a huge thing to deal with. On the other hand, because there had been a precursor event, the local community, the decision making, the authorities were well aware, and they'd also taken many measures. They'd relocated a whole campground. Imagine this debris flow, the ensuing debris flow running into a campground in mid-August, right? I mean, that doesn't stop at 8, right? It did do some harm, but the mayor, she was briefed. She had the relevant telephone numbers. The measures had been taken. An alarm and warning system had been installed. She got alerted ahead of the event. Still, of course, I mean, there are casualties happening. Little rockfalls and Cengalo and big ones like Cengalo aren't the only thing. Just 2 years back, there was this ice break off here on the Marmolata that didn't send many signals ahead of time. Also here, 11 people got killed. So this is happening very close to our environment. Yeah, this is not confined to other decades or once in a century and other continents. But if we look to other continents, we see things that are 10x the size. Yeah. The mountains there are higher, but so are the valley floors, and so the topography, it has more cryosphere. Its glaciers start at a lower, relative from the valley floor, at a lower thing, and it goes higher up. But the topography is not that much different from our valleys around here. Yeah, and this would mean, Obergogel-Telfs. Yeah. 150 kilometers out the valley or something like that. Yeah. This devastated 2 hydropower plants, and I assure you that we would. I mean, in Asia, the society is working a little bit different, and they're happy rebuilding. I'm pretty sure around here we would not talk about rebuilding if we had something happen at this scale. Yeah, because in the end, somebody's got to pay the insurance premium. Yeah, and I don't know if you get another insurance for that. Okay, not to shock you totally, but there's more. Okay, people don't live here. This is a bush pilot in Alaska, or BC actually, that flew over this one and saw this. There's also first-hand evidence of such events that comes from space first. So the International Space Station saw the Kolka-Karmadon event in Russia, in Caucasus, earlier than Russian authorities were alerted, and that was also on the order of 120 or 150 people killed. I don't have it in this talk. Yeah? Also, these things happen spontaneous, and sometimes they happen in sequence. So this one had a second large debris flow here, layer on top of the other one. Yeah. Here, no one's living, no one's impacted, but the Elliott Creek event went into the fjord and caused a 100-meter high tsunami wave. So if you have your fishing station or your oil terminal somewhere out on the coast, hold on, right? And I mean, and you see that if you follow the years, I mean, this is all from the 2020s, yeah, more or less. Yeah, this is not black and white pictures. Yeah, And I already mentioned, of course, slowly and slowly we see more of these events in the Eastern Alps. Last year, the Fluchthorn is something that no one had on the charts. There has been very, very, very little precursors, so no significant precursors that would alert authorities or scientists. In hindsight, researching, I found a local climber from Paznaun who wanted to summit the day before this broke off, and he turned around just on the summit. Yeah, I talked to him. He has some nice footage with crumbling stuff, and he explained why he turned around, because it didn't look so good anymore. This one, different to Bondo, it didn't hit any infrastructure. I mean, yes, the water system of the hut got damaged. There's a hiking trail, but I mean, so me personally, you know, one hiking trail, that's okay. Then you just go on to the other hiking trail. But it stopped just short of the hut. So here we were very lucky. What you see again is a huge scar, a huge fall line. Then down here it hit the glacier and melted the ice, and then went on, and it really went on, you know, like a wave spilling all around. Yeah. Easter, up the Inn Valley in Pontresina, Piszczerzen sent off a 5 million cubic meter rock plus about 1 to 2 million cubic meter of glacier lying on top. And that, of course, had a much more water. And those of you that have been into Val Morterac, so Cerva Hut is back here on the side, yeah. And if you, many people take a bike in there and then leave it. This is basically where you deposit your bike to go to Coats or Cerva or something like that, yeah. And of course, the main concern after it was down was for infrastructure and well-being further downstream, because this lying here with a lot of fluid water and little puddles, and where is this water channeling, and will there be another outbreak, will it go on, and so on. So that was really a 2 days of crisis, yeah, in April this summer, yeah. Yeah, and if we look at it in detail, you see here, you see an aquifer, you see fluid water squirting out for the first 2-3 days. I don't have the very exact, all the data and so on, but I heard from colleagues, yeah, it's been squirting out fluid water. And, you know, common law at that altitude would tell you it should be frozen solid, but obviously it's not. Yeah, so we have thermal effects inside, and we have new waterways despite the glacier sitting on top, and this here looking like pretty frozen altogether. Yeah, so detailing these processes is really important, and we're working on there. You're happy to join in the fun. And for the last part, I want to get back to response and also adaptation to these challenges. Yeah, so one thing I hope to make my point is we desperately need more expertise in this field. We need more people. I'm working in a research area where there's no competition from North America. Frozen rock walls is not researched in North America. I don't know any other research domain where this is the case. Yeah. But there's also other aspects. Yeah. So we've been working with authorities for these obvious hazards. Like here, this is material being pushed into a river from a rock glacier. So also in Matterhorn above Herbrechten, we'll see the rock glacier in just a second. So the material here is pushing, and seasonally, you know, this goes into crisis mode, pushes the material into the gully, and then of course this with further water goes all the way down onto the road and next to the houses and so on. And the mayor there, she had to get I don't know, 5 excavators and 14 trucks on Sunday morning to empty out the protection measures. And it's not just that. Yeah, somebody had the great idea to do a hiking trail right through that. Yeah. And for many years, this hiking trail has been maintained at great pain. Yeah, you see, I mean, there's the aspect of risk of getting average hikers into such environments, but also the pain of putting workers there to fix it every year, and so on. And the pinnacle of a pain, you know, it's not just for the hiking trail; it's also for the village. Has been here where we are having slope velocity measurements using GPS. You see then how well equipped we are actually to manage hazards when it really comes to the extremes. So this piece of rock at the top of the Grabengufer rock glacier was standing free over time, more and more free, and people got concerned that it would roll and topple off. And then the decision was taken based on the evidence from our data and from discussion and knowledge assessment, expert assessments, that this should be blasted away. And so I spent a day with Alessandro filling Tovex into his little boreholes. Not just one bore. So he spent 3 weeks up there drilling boreholes into that rock, right? You see, so our response here is very professional. Yeah, it's. I mean, the Alps people are very experienced. We have great experts. This was live broadcasted down to the village people. Big national and yellow press style media were completely kept out. They kept that secret locally. They had local press comment on that because everybody knew this is a 50-50 thing. We don't know if that's going to work. If that rock, you know, stays in a larger piece that's fragile, you can't open the road. You can't open the school next day. Yeah. And that's that decision, and the measures were taken based on knowledge and interaction between scientists and decision makers and industries, professionals. Other very quick example were also where our research has been leading to successful mitigation measures is here in Weissmies in Saas-Grund. So for 3 years, a hanging glacier was monitored, and then just before the main part failed, there was an evacuation of 220 people in Saas-Grund for less than 24 hours. Yeah? So we were pretty good on the prognosis of that hazard out there. Yeah. I already mentioned this first borehole in mountain permafrost in Kovac. And you see here that, so this is the site, this is the rock glacier, the borehole is just where the little rock here rolled through. So it destroyed one of the oldest research evidences there. We spent, over the PERMAS team, we spent about a year deliberating whether we could still go and work at this site or not. And that's also a form of response, right? And possibly also responsible conduct. I mean, that's for other people to assess. Yeah, and we got together this summer to clean up all the rubbish and to salvage as many of the experiments as still can be done. And they're all highly automated, so you don't have to go there to get data as much. And we'll probably not have field trips with school children and journalists to this site anymore, which is a shame. Yeah. Yeah. Okay. Last 2 pieces on response. So Cengalo that I showed earlier happened. The main event happened in 2017. It took about a year, I guess, to clear up and for things to calm down. But we see that in today's world, it's not just about the rocks. Yeah. And so the response is ongoing. And in August this year, 5 people are now prosecuted in federal court in Bern, including the mayor who was responsible for the whole thing. The mayor and 4 experts from authorities and from engineering offices. And my projection about this is if this gives us a precedence, we'll have a hard time recruiting new mayors in all of the Alps. Because in the end, the mayor is responsible for public safety in its area. Yeah. So that's one to watch happening in Switzerland, but of course, you know, just over the border from here. So really something that could have happened here. And the last thing is where Rainer started. On Monday, a friend of mine showed me a WhatsApp photo of, you know, have you seen the rockfall? And I said, no, I am really interested in rockfall. And this one took a while until it ended up in my WhatsApp box, but this is also the first one that a significant rockfall really hits tourism infrastructure and hits operational ski slopes. And we'll have to see in the next weeks how this develops. Yeah. And with that, thanks a lot for your attention, and I'm happy to discuss on one last pitch. So yeah, we've been part of a movie cinema scale production, so not the average evening science TV thing, but the cinema production, Bergfahrt. It's around different cinemas. It's been in Leo Kino once. It's supposed to come back. I don't know exact dates for Innsbruck yet. It's going to be in Radstadt at the film festival. We screened in film festival Locarno. So if you catch that, pretty cool movie to watch. All right, thanks a lot.
So, hello, thank you. Thanks a lot. Yeah, now we feel free to ask some questions. We are in the Q&A session now, and for the participants, for the online participants, just write in the chat if you have any questions, and we can answer them. And to the audience, if you have any questions, raise your hand. I'll bring you the microphone. I'll test. 1, 2, 3. I hope it will work. Okay. Yeah, any questions?
Yes.
I hope it works. Just test.
Thank you for the very interesting presentation. Finally, you just reported about the rockfall in the Pitts Valley, which happened actually 1 week ago.
Yeah.
So the news came very, very late, probably because of the ski opening in Sölden or something like that. I don't know. What I want to ask you, you live in the Pitts Valley, so I assume that you are well informed about the plans to expand the ski area on the Mittelbergferner. And so I want to ask you, do you think it's justifiable to do constructions in respect of safety and from the scientific point of view?
Yeah. All right. So we kick off with politics first. That's good. So Gerd, yeah. 2 points. So the news came late. Yes, I'm super surprised. The glacier ski resorts are packed. They're at maximum capacity these days. So is Pittstal. Everybody's been taking photos down from the cafe onto that rockfall. The photo I have, some relevant people in the valley received it via tourist acquaintances from the Netherlands. So it really, it detours all around. I'm super surprised it didn't hit a larger audience earlier, because some of the evidence I've been showing, some of the stuff, it's online or it's sent around between certain peers the next day, the very same day. Very, very, very special case that it took so long. Will be interesting to follow up. Also, if you've read, I assume you, many others have read very exactly what the press thing said, especially the first one. Remains to be seen, and that's response, right? And with the whole society. Okay. The other thing about future developments, we can build a lot. We have built a lot. We can epoxy the whole stuff together. So far, the banks have been pretty happy to spend on a lot of extravaganza in the high mountains. Yeah. I'm not so sure going forward whether the financial sector is still willing to pitch in at the scale at which things have been going. So the recent or the flagship ski resort development, or well, yeah, Alpine destination development from a technological perspective cost 500 million, and that was the Vauban in Grindelwald. Yeah, I mean, yes, Vauban, so it's 2 cable cars and a little bit of a subway station up the Jungfrau and so on. So it's not just one cable car, but it's one project which is 500 million. If we hear something about the the new CHIPS Act and the semiconductor biggest fabrication facility you can build in our times is 10, 20 billion or something like that. So I don't think that'll scale up. Yeah, in terms of pure finance and what you want to have. You can manage, protect a lot of things, whether that is workable in a reasonable business model and whether that's fun for the fun-seeking skiers. I'm also part of that. That remains to be seen. Yeah, the specific project has been sitting around, been discussed for so many decades, as you best know. It's never really been close to materialization. So there's many factors in there that hint to difficulties in realizing it. Yeah, not just politics and decision making, but many factors. Yeah, but building, you can build a lot. Whether it makes sense or not, that's a different thing, right? And that's yeah. With a microphone on, I'll leave it at that. Yeah, but it's difficult. Yeah. No, but one thing that we can say for sure. I mean, couple St. Anton was killed in court. That's a precedence, right? That's a reference precedence. That's a fact. That cannot be rolled back, right? And if you look at the reasons, yeah, that's a line of argumentation, yeah. But this has not been realized since building those 2 ski resorts in the 80s, yeah. It's always been that close. You could have always prioritized that and not built another ski lift. It's never been done. So remains to be seen, but it's yeah, we can do a lot. There's been many proposals. Also, in the old days, the original Jungfraubahn railway wanted to go to the Jungfrau summit, and there's been both a Swiss and an Italian proposal to build a cable car into the Matterhorn summit and have a walkway in that summit. Yeah, so there's many dreams, right? But I think ultimately finance will limit certain endeavors. Yeah, because it is. I mean, we've scaled for since 1900. We scaled. Yeah, and yes, certain things will continue to scale, but yeah. right.
Yeah.
That was long.
Thank you. Other questions? Just raise your hands. There's one.
Here.
I have just a quick question. You showed the pictures from Obergurgel. Is it Rotmusferner and Wasserfallferner, or what are the names of the glaciers there?
I know it's rock glaciers. It's Äußeres and Inneres Hochebenkar. So it's just if you continue direction Ramollhaus and from the ski resort, you inwards, you continue west, and they're just hidden. You can't see them from Obergurgel, but it's just there, and that's these two rock glaciers. Yeah, and this is where yeah, there's been ongoing research, and recently we're have installed a permanent GPS and some other things, and IGF, Lea Hartl installed and Andrea, they installed a webcam out there, which is public, visible, and data and so on, and there will be more. Yeah, and it's a nice super site kind of thing, and it's so close to campus, right? I mean, it's Obergurgel is part of the university.
With cases such as the Piescherchen, where there seems to be melting permafrost underneath a active glacier, how does the modeling or the forecasting keep up with situations like that? Like, how do you see that going on in the future?
Yeah, it's a pitch for at least 5 different PhD theses that have not been written. No, this is at this scale is probably the first one with such a lot of ice on top. Hasn't been seen yet, hasn't been modeled really. There's lots and lots in, of course, in steep terrain of all kinds in non-frozen conditions. Yeah, and permafrost is yeah, we're worldwide is 20 people, you know, half of what's here. Yeah, that's it, and no one from North America, and cross-disciplinary is so important. Yeah, we need hydrology that moves also into the frozen element at the pore level and at the macro element. Yeah, the stock hydrologist works with fast flowing fluid water. Yeah, we need the atmosphere interaction, the geomorphology, geophysics, geology, the whole thing all together. So that's is a huge challenge. Yeah, we've been debating a little bit up and down about this water aquifer, but yeah, it's without direct observations and direct evidence, it's a hard time. I mean, I talked a lot about Cengalo, and Cengalo has to this date, Cengalo has not yielded a single in situ data point. That means no one's ever walked around up there and, you know, taken a specimen or measured something or installed something. In the early days, it was not possible because there was all this mitigation measures, and of course, you know, people die, and it's very difficult to work in such an environment. And before the big detachment, there was actually a whistle. Don't go. Yeah, and so. And I guess there is now more and more an awareness that, you know, knowledge is key, right? And experience is key. And we're working that direction. But then, you know, a personal opinion, business interests, they collide. Yeah. And that also limits the thing. Yeah. And but that's so super interesting to kick in there. Yeah, I've been looking a little bit more into energy balance slash water hydrology and steep rock faces. But yeah, this would be a cool new scenario.
Yeah, I think this lecture series is also about science communication, and yeah, my question is, do we have enough science communication, or how to bring all this knowledge to the media? I have the feeling that the media don't communicate this enough. So I have the feeling you showed around 1 hour pictures, which are really shocking, but in the media they are not so present. And the knowledge transfer and science communication and media, do you think there should be more, or how to communicate it better to the media?
It's difficult. It's not just the media, it's also the media consumption. And this is why I started my pitch with glaciers and the general climate diagram that's out there. And I noticed a few things that complex climate data diagrams in today's evening news are not explained like in a scientific lecture. You know, this is on the axis, and I also, you know, I wanted to just give you more impressions and not lecture in detail. But if I would be giving a lecture, I'd be talking about what's on the axis and what's the color and what's the significance. You see Ingo Zamperoni in Tagesthemen throwing these ECMW simulation runs onto the screen, like what I had at the pitch, and yeah, okay, that's the newest data and it's warming, and then they move on. Yeah, so that's one thing. So obviously the complexity today on a meta level is understood, but then there is a barrier, you know, to give it more time and more allocation, and it really boils down to discussing these things, having knowledge, knowing these things, exchanging views, gaining capabilities. The other thing that I noticed is that in the general climate discussion, they always talk about Fiji and sea level rise, and you know, they show these images with that city council or whatever it was underwater with scuba gear. You know, that's reused and reused and reused. The oldest, shittiest black and white photos from the Alps with glaciated peaks at you know, at the first days of photography show visually what's happening in our times. I mean, it'll be a long time until we can see sea level rise. I mean, really see it. I mean, you can measure it, yes, and there's going to be islands that are spilled over, but seeing it in an equivalent way, like these glacier deltas that I showed here, is going to be very difficult. But on a global scale, mountains don't matter. Mountains are poor people. Historically, they matter. They were strategically important. Natural resources were harvested in the mountains, but now it's in high latitude environments. Gazprom, Esso, diamond mines in North Canada, they make their money there, right? Geostrategy is going out around there, not here. You know, Hannibal's times, the Alps were important, and crossing the Alps, and salt mines here, you know, around, and other ores and stuff like that. But today it's 700 poor boogers compared to 3 billion at coastlines, right? And the money being made at coastlines, and you know, military using coastlines. So that's another thing. But yeah, exchanging, making it important, discussing, and true knowledge. You know, I'm yeah, rather fresh still here in Innsbruck, and probably gave permafrost as a topic, you know, a 2 to 5x with what's been going on here. I hear the term a lot, but there's not much depth, yeah, all around, yeah. And yes, there's experts, there's great peers, and so on, but on average, that needs to be developed, yeah. And this is why communication at all levels, I mean, from, you know, pleasing cinema to hard facts, and also just shocking is not good, yeah. So it's difficult, but what I really notice is that mountains don't appear in the international climate dialogue. Also, you see this special report on cryosphere is a recent IPCC publication. There's been 6 iterations of these IPCC reports until the first time a special report or a chapter on mountain was mandated. Yeah. So for us, the mountains, living here and enjoying it is part of life, part of our DNA. But there's so many other people out there where it's not. Yeah. On the other hand, I'm happy that people like to go to soccer stadiums on Sunday and not go to the valleys, so I can, only meet 5 people and not 50,000 in Bayern versus Dortmund or something like that.
Yeah. Any other questions? There's some.
Yeah.
So how do you deal with the knowledge in your practice as a mountain guide, or has it changed a lot the way you go to the mountains?
Yeah, great question. As a guide, well, whether guide or not, yes, it's changed tremendously. It's no, you have to abandon certain things, abandon dreams, concrete plans, change them, change strategy. There's the good and bad. I always wanted to, I always had the American direct on the Dru in Chamonix on my climbing tick list, and then half the thing fell down, and it's still being climbed by some people. I so far have chosen not to. That's kind of a dream I'm not willing to realize these days. So there's other summits out there. The other thing is that I think traditional traits are becoming more and more valuable. So the traditional way of mountaineering, the traditional way of guiding is gaining in importance. That is not booking via app for the next 5 minutes and just coming one day. So when, occasionally when I'm at my research site in Matterhorn, I get this phone call, hey, can you take over a few clients, tomorrow, the day after? They fly in the same day with Air Berlin. Because of a lot of people being well trained and doing marathon and stuff like that, and that they're increasingly in good physical shape. But they flew in the morning, jog up to the hut, haven't seen crampons in, a longer period of time. You do the thing, the last hour down, oh yeah, this is so great, let's go sit down, have a beer. Then you arrive at the hut. They rush inside, repack their bag, ciao, because I can rebook my flight and be back home with my family for dinner. Yeah. And I think this is, we are seeing a little bit less of that and a bit more of the old qualities, because here or in the Western Alps, you'd come for a week, you check out your physical fitness, you check out the weather, the environment, get a guide, and then go from small to big and things like that. Yeah. But yeah, no, it changes a lot. The most significant changes, if I can get 2 to 3 good powder days per year, it's already a pretty good winter. During my PhD, guiding about 100 days a winter in Arlberg. Sorry, during my PhD, yeah. We had 80 of those were top powder days. Yeah. I don't have the freedom to take off on most Mondays, so I could probably have 10 good powder days if I had more flexibility from the job and family perspective. But that's changed radically. Yeah, and the recipe is less apps, more mileage, and look out the window in the morning and make your weather report. Yeah, the offerings we have here, what Patrick Nayertz and team are doing for the winter season is absolutely fabulous, but you need the competency yourself, and you increasingly need it. So Spaßgesellschaft, yeah, it's more difficult, but it's changing dramatically. And you saw the Wildspitze thing, yeah? I mean, yeah.
Okay. Yeah, the time is passing fast, so maybe one very last question, or somebody. I have a look on the chat if somebody asks some question there.
Oh, yeah.
No, there's no question anymore. Yeah, then I would say thank you very much for coming. Thank you, Jan Beutel, for the presentation. Right. And yeah, see you in the next lecture. And tell all your friends to come also. It's an open, open lecture. So people outside of the university can also join. You're really welcome. And yeah, thank you for coming. Bye.